The course is called Introduction to Structural Materials. It has three different numbers. One is an undergraduate course number, which has got an S, which is some sort of experimental or something. 3371 is a graduate course that I've taught for years. And 2821 is a joint number with the Department of Mechanical Engineering. I'm the instructor, and here's the contact information. You'll have this. You don't have to be taking notes as we go along. The administrative details in the course are such that you need to have a sign-in sheet, and Brian Holman will be my assistant on this, and he will be playing this video for you on Monday and answering any questions. He'll pass around this sign-in sheet. If you don't get the sign-in sheet, you can talk to Jerry Hill, my assistant in my office, which is just basically across the hall. She's in 4138. I'm in 4140. I basically don't trust the registrar to get things right in terms of class registration. At least they don't until well into the term. The schedule is basically, in general, we'll meet every day that I'm around, although since we're going to be doing this more as an online option, we're not going to have a lot of days that we're going to be meeting. Our actual meeting times and your presentations, which we'll get to, should be done by the end of June, although you may not finish watching all the modules until later in the semester. The semester essentially ends about mid-August or so. You can check with the registrar. But essentially every day that I'm here, in general, we'll meet and we'll complete things by the end of the month of June. It's going to be early in the morning, usually starting at about 8 o'clock, unless there's some conflicts, and we'll run till 9:30 or so on the days we can. It's my understanding this first week, because of the 2N students, 2M students have a conflict, they're going to we'll only be able to meet until 9 o'clock on those days. But we'll work all those details out as we go along. There are live lectures, which we'll take care of in the first part of the semester. Student presentations, I said second month. It'll actually be in this first month, since this is the summer semester. And you really need to watch 3 of the 12 lecture modules, totaling 36 lectures, which essentially makes a full course at MIT. There are a couple of half-lecture modules that are 6 lectures approximately, and if you want to do some of those, you should do 2 of those. Now, the actual modules that we have available for you, if you go to my website, eager, and you have to make sure you spell it with an AR, not an ER, .mit.edu, and click on classes, you'll see the ones that I've lectured, and we have video presentations on material selection. I've done that 3 times in the spring, fall, and fall of those years. Welding metallurgy, solid state welding, and fusion welding. The 2N students are actually required by the Naval Sea Systems Command to select these 3 modules. You don't have a choice so far as that goes. Other students who are not in the 2N program are free to take any 3 of these or the ones on the next 2 slides that are lectured by other people. But essentially, NAVSEA requires a welding course, and these 3 modules make up the welding course. There are actually earlier versions of the welding metallurgy, but this is the most complete. I've taught a lecture on what is engineering, sort of an experimental thing last fall, where I basically was trying to figure out for myself what's the difference between science and engineering. And we talk about what it is that engineers really do. I've taught a couple of times something on codes and standards, and if people are interested in that, we can discuss that when I'm back on Thursday. Deformation processing, I've taught, actually I taught that when I first came here 40 years ago, but I taught it again in 2012, and that's on forging and rolling and sheet metal forming and things like that. Materials processing and casting I gave back in 2011, if people are interested in that module. These are all 12-unit modules. The next series are by Dr. Simone Belmar. And Dr. Belmar is a graduate of this department. He is, his specialty in his thesis was fracture and fatigue, and he now lectures, and as you can see, he's done several half modules, 3 of them in here, but he's got some on materials processing, sort of a condensed version of what I've done in 4 or 5 modules together, which includes casting and forming and things like that. Structural materials, since he is a mechanical metallurgist, he's talked about structural materials, environment and mechanical behavior, and structural life assessment. I should go back to one of mine. Material selection on here is sort of an introduction to a wide range of materials, why we use metals for structural materials as opposed to ceramics and whatnot. The last one, when I was on sabbatical a year ago in the spring, I had Dr. Belmar taught one module. Dr. Jenkins, and one of my former students, who's now also an MD, actually talked about non-destructive evaluation of a human body. How does a doctor do an examination on a patient? And so if you're interested in biology and things like that, you could watch Dr. Jenkins. And then Steve Lyons, who's a graduate of MIT, actually from the Sloan School, but is now a practicing attorney in Boston, gave a module on intellectual property, law, and technology, which has been well received by a number of students. So you have a wide choice. And in fact, during the academic year, students are allowed to take this course twice or even 3 times, because you see there's more than 9 modules. As long as you take 3 different modules each time, it says in the catalog you're allowed to repeat the course, except for the 2N students who have to take what NAVC says. The requirements: watch 3 of the modules, either live, but we're not having them live this summer. You'll have to do most of them online, or by video, which is the way most of you will do it. Now, the 2N students also have another course. I think it's 2690 on corrosion in marine environment. And when I come back on this Thursday, which would be, June 9th or something, I may give that lecture, or start that lecture on the corrosion. And I'll talk about that, the requirements for that course. But that's designed primarily for the 2N students. I've had other students take it if you're interested in corrosion applied to the marine environment. So there's really, for the structural materials course, you've got to watch 3 modules. The 2N students will have to come a number of days over this month to do the corrosion. You've got to prepare a 1-page outline for each module that you take. It only means 1 or 2 lines describing the key features of that lecture, and we can talk about that later. But basically, you'll find that typically in a 1-hour lecture, an instructor can only get across 1 or 2 key features of what he's trying to talk about. And you need to be able to pick those out and realize that a lot of the rest of the stuff is just sort of extra material that you don't have to worry about. You need to make a 10-minute presentation to the class as a whole, and we will be meeting probably the 3rd week of June, which is, I can't remember the date right now, but it should be June 20th or so. I'll be asking 3 students a day. So in 3 or 4 days we should be able to, or certainly during the week, we should be able to complete those. If that doesn't fit everyone's schedule, I have had students videotape their own presentation and submit the presentation to me. But you have to watch the other student presentations. Tentatively, we have 16 students signed up for the course. And whether we will videotape the presentations, we're not going to post them on YouTube, but we will post them so you'll be able to watch each video presentation. So even students who don't want to show up at 8 o'clock in the morning can watch the videos at their leisure. So you can do it at 8 o'clock at night if you want. My favorite student comment was, one student said he He watched the lectures while he's preparing dinner. Okay. Your presentations can be on any materials topic you like. I always say students will do a better job if they are essentially interested in what they're talking about. 10 minutes means you've got to prepare. You shouldn't have more than 10 foils or overheads in order to make your point. You shouldn't be something too general. I don't want how to solve world hunger in 10 slides. I don't want how to build an automobile in 10 slides. I want you to get into something more specific that's not too broad and that you can ask a question and attempt to answer it. You don't have to cover too much. I've had students do pole vaulting poles, which are actually a very interesting composite, both in how they make them, but also how they lay them up so they get a different stiffness along the length of the pole. I've had people do running shoes, and I've had people do ballet shoes. I've had people do doorknobs, decorative doorknobs, and how they're manufactured. The 2N students' presentation will probably be on either corrosion or welding, and it will probably come from some of your own experience in the shipyards or on board ship. But the rest of you students, I mean, one student, I think, I've had students from the nuclear engineering department. I think we have one here from the aero and astro department, and they often do something that relates to their interest in aviation or in nuclear energy. Some particular problem, like the Davis-Besse problem. The Challenger disaster of the space shuttle may be a little too broad, but you could home in on something like the impact damage. It wasn't the Challenger, but the other space shuttle where the foam hit the front, the leading edge of the shuttle, causing the damage so that it failed on reentry. Well, just looking at that foam damage would be a narrow enough topic to cover than the design of the space shuttle as a whole, which would be a little broad. I'm asking you to tell us what you think about the topic, okay? Whether it's correct or not. So far as Navy students go, a number of students have done the Sheffield cruiser, which was a British cruiser in the Falklands War, got hit by a French Exocet missile that the Argentinians hit it with, and that caused a fire and wiped out a capital ship of the British Navy. The question is, was that fire an aluminum fire where the superstructure caught fire or not? And there's some debate on that. So if you want to do something like that, you can kind of cover what you find and then, for example, and then tell us what you think. Grading, well, you're going to find, I'm going to talk about my teaching philosophy in a second, but you're going to find I have a different teaching philosophy than most people. There are no tests, no quizzes, and no finals. You don't get to show how smart you are in front of all your classmates. Actually, you do. You can make a presentation, but you're not going to be doing it on a comparative basis. There is obviously no problem. I'm supposed to talk about interaction with other students. Well, there's no problem with collusion. You're just here to try to learn and enjoy things and make a presentation on something that interests you. So there's not really a problem of collusion. You're free to talk to each other about whatever you like. You'll be evaluated on your presentation and participation in class, except we're not going to have as much participation in class, so mostly you'll be evaluated on your presentation. And we'll talk about that some more when I meet with you live. Completion of 3 one-page outlines on the modules you watch. This basically helps prove to me that you watch the modules and you try to gather the critical information from those modules. I'll tell you a story about that in just a second. And you'll have to submit a list of the other student presentations you watched, which in this case, you may not have to submit the list because there's less than 20 students. You may just have to confirm that you watched all the 16 presentations, actually 15 other presentations. But to go back to one-page outline. So let me tell you what happened to me. I was an MIT undergraduate, came here in 1968 as a freshman, and graduated 6 years later with a doctoral degree, went off to Bethlehem Steel Corporation for a couple of years, and they made me a welding engineer. I came back here in 1976 as a faculty member, and I've been here for 40 years, as of July 1st of this year, except for a one-year sabbatical in Tokyo, Japan with the Office of Naval Research. But what happened to me in my junior year, for whatever reason, I took an elective course, which I really had no business taking. It was Introduction to Quantum Mechanics in the Physics Department, okay? And solid state materials and quantum mechanics are related in a number of ways, so I thought, okay, this will be a way for me to learn a little more physics. It's not part of my requirements, but I can learn what's going on in quantum mechanics. Well, I didn't learn a whole lot about quantum mechanics. In fact, I was getting 15s out of 100 on the homeworks. I didn't have a clue what was going on in that class. Everybody else was getting 85 out of 100 on the homeworks. I had a very good teacher, is Vera Kistiakowski. She was one of the first, if not the first, female full professors of physics. Her father was a Nobel laureate at Harvard in chemistry. She always brought a great big German Shepherd, as I remember, to class. And she was a very friendly and competent lecturer. I just didn't follow quantum mechanics very well. So by the end of the term, we had to take a 3-hour final. And so the night before, I thought, well, I'm just going to flunk this class. I really don't know what's going on. But I decided to take the textbook, Foundations of Modern Physics by Iceberg or something, and just go through it and try to pick out the highlights, okay? Even if I couldn't put everything together and all the details that they instructed us in and stuff and the homework problems, let's just figure out what the highlights were and I'll go into class and see what I can do. Well, I went into class and I finished the 3-hour exam in 1 hour and 15 minutes. I had to wait around. I think there was a requirement you not leave before 2 hours or something on the 3-hour exam. So I checked it over. I sat there and kind of twiddled my thumbs for a little while and left and felt that I'd done pretty well on the exam. Well, I ended up getting an A in the course, which shocked me. I mean, I was just dumbfounded. But then I realized, oh, all that other stuff she talked about in class was all fluff. It was just the highlights. And really, that's when I realized there was really only 1 or 2 themes in each class that the professors were talking about. And if you can figure out what that theme is, all the other stuff is just fluff. So from then on out, I quit taking notes in class. And hopefully you don't have to sit here and take notes. I would just sit there and try to, I called it guess my lecture, okay? Or guess my outline to my lecture. I would sit there and try to figure out what is it that the professor's outline really says. What is the 1 or 2 themes, maybe 3 themes that he's trying to get across in 1 hour? Because frankly, I've learned over the 40 years, that's all you can really cover in 1 hour. So for me, it's sort of a watershed. And when you have to go through and make a 1-page outline or a 2-line outline of each lecture out of 12 lectures and combine them into 24 lines or so of a 1-page outline of the module, hopefully that's going to help you learn to focus on what the key points are. A number of students have pointed out that they learned a lot from the other students' presentations. A couple of them even suggested they learned more from the students' presentations than from my lecture. Let me just warn you, it doesn't do any good to insult me, okay? Actually, it doesn't do any harm either, but it doesn't do any good. So let me, unfortunately, I can't ask for questions because I'm not here live with you, but let me just say a little bit about my teaching philosophy. First of all, I decided about 25 years ago that if MIT wanted to remain preeminent as an educational institution, We weren't going to do it by having more and better research. There were too many other good universities out there. They were getting funding various ways. Many of them had been MIT students who are now the faculty at these other schools, so we were competing with our own former students, many of whom were brighter than we were on the MIT faculty. And so we needed to focus on something else and change if we wanted to remain preeminent as an educational institution. I learned about 1990 that at that time, in 1990 dollars, we spent about $80 billion in the United States on post-secondary education, okay, so college education. But we spent $90 billion, 10% more, on continuing education, where industry would basically fund people to bring them up and teach them what they thought they really needed to know. Not what they learned at the university, but what they really needed to know. And so there was a bigger market for continuing education than there was for college or university education. So I started then looking about the same time. My children were starting to go to high school, and every now and then I'd be eating breakfast. Everybody else was still asleep because I used to get in pretty early in the morning, like 4 a.m. And so I'd be eating breakfast, and they'd leave their math book or something on the kitchen table, and I'd flip through it. And I realized, for example, one of my children's math book had 2 pages on every topic. 2 pages on derivatives, 2 pages on integrals, 2 pages on exponentials, 2 pages on logarithms. I had no idea that mathematics could be separated into uniform 2-page modules. Everything we needed to know could be condensed into a 2-page topic. Well, obviously that's not true, but what was happening, all they were doing was training the students, these high school students, to take the SAT exams or whatever other exams they had to take. And so we spend too much of our time asking students or preparing students to take tests rather than focusing on actual learning. As MIT students, you wouldn't be here if you didn't already know how to take a test. You're one of the best in the country. In fact, MIT undergraduates are in the top 3 out of 10,000 students in the country. Something like close to 50% of MIT undergraduates were valedictorians in their high school. I was number 8 in my class of 200 in my high school, so I was way behind. I didn't get admitted to MIT on the early action stuff. I had to wait until all the regular stuff. I came here, found out I was in the bottom third of my entering class. So I didn't like tests. I thought they were somewhat artificial. I don't like problem sets. I think they're very artificial. But I also know that MIT students know how to take tests, and so what do we need to compare ourselves to one another? Another thing here is the subject's not required for anyone except for the 2N students. So let's have fun. You're taking the course because you elected to, not because you're being forced to, except the 2N students. And so let's just try to do this in a stress-free environment. MIT is always talking about, can we do something to reduce the stress on students? So I'm doing it, okay? You should think of this as a stress-free course. I've only given, I guess, 3 grades. I probably have given an A at some time in the last 30 years. I've given A's in the last 30 years. I probably have given an F sometime in the last 30 years for someone who didn't come to class and didn't get themselves off the registrar's list before the end of the term. And I was told that I cannot give an incomplete if they haven't done anything. So I had to give an F, and they later got that expunged because they proved to the registrar they didn't ever intend to register for the class. And those problems haven't shown up so much in recent years. I did give a couple of B's a few years ago to some graduate students who came in and did presentations. It was like reading the Wall Street Journal. It was just pure pap, okay? And if they had learned anything from my lectures, they should have known that I don't care for Time Magazine or the Wall Street Journal's science, okay? And all they gave me back was the same type of junk, so I gave them a B. But in general, you don't have to worry about grades, okay? Stress-free. A good teacher makes things simple rather than complex. You'll find there's a lot of professors out there who like to show you how difficult something is and how complex. That just means that professor's insecure. They want to prove that they're smarter than you. Well, I already know. I entered this place in the bottom third of my freshman class. I know the students are smarter than me on average, okay? So I'm not here to try to make things complex. I'm here to try to make things simple, okay? I wanted to show you that you already know a lot of the information, and it's just how you put the information together, sort of inductive reasoning rather than deductive, to reach a conclusion. You already have the tools to figure out most of the things you need to know. You just need to keep focused and learn how to do that sort of inductive reasoning from other things you already know, or things. And so I'll give you some examples of that. No one ever showed me how to do this, okay? I had to learn this out of the gutter on the street, but it's been very effective in helping me understand things. So induction, deduction, extrapolation, estimation are all techniques, and there are methods of doing this that will serve you well in all fields, not just welding or deformation processing, but throughout your life. So the first rule is keep it simple. This is also known as Occam's razor. The Earl of Occam, back in the 1300s or whatever, said in Latin, frusta fit per plura quod potest fiere per paciora, or something, which means it is futile to do with more than things that which can be done with fewer, which is a complex, non-simple way to say keep it simple. Or some people call it the KISS principle, keep it simple, sir. And so the philosophy here is let's try to learn things and not toil about things, okay? I already mentioned some of the teaching secrets. You can only cover one or two concepts in an hour. The rest is all fluff, okay? So that's one principle. Another teaching secret is when they give you an exam, particularly in science and engineering, they like to give you something nice and simple that has a determinate answer, such as 3y is equal to 15. What's y? You calculate it, and it's 5. And when they're grading that, all they have to do is check off. You either got 5, or you got 4.5, or you got 10. Whatever it is, you either got the right answer or the wrong answer. It takes a microsecond for the instructor to be able to see that and give the grade. If you have something that's an expository, what do you think, then that takes a lot longer to grade. And I've done both types, and I can tell you it's much easier when you got a class of 50 students and you give a quiz and you got to grade it to do the first type rather than the second type. That's why we give you numerical problem sets, okay? Now, why would someone spend an entire hour doing a derivation in a class? Okay? Anybody got an idea? Turns out the answer is because they didn't have time to prepare a lecture. Now, this came across very vividly to me 40 years ago when I was in the second semester here as an assistant professor, and I was teaching the deformation processing class. And I had been traveling the couple of days before, and I got here and I had a class at 9 o'clock in the morning. I usually have classes early in the morning because I'm a morning person. You know, my schedule here is, nowadays it's kind of 7 to 3, okay? In the old days it was kind of 4 to 5 and 4 in the morning to 5 in the afternoon. But now that I'm closer to retirement, I take things easier. In any case, I came in and I looked, and I didn't really have a class prepared for this deformation processing, so I looked in the book I was using, which had been a professor here, and I'd taken the course as a student, graduate student, and so I supposedly knew something about it, but there was a derivation. I said, oh, I can spend the class doing the derivation. And all of a sudden a light went off, and I thought, oh, so that's why professors do derivations. They didn't have time to prepare a lecture. They're just coming in, and they're going to waste everyone's time. You're all going to fall asleep. The professor's going to make a mistake, okay, in the derivation. So that's what I did that day. I went in and I did the derivation, but I also promised myself I would never do it again. And I have never done it again in 40 years. I have never done a derivation in class. If a derivation needs to be done and the derivation is not in the book, I will write it out ahead of time, I'll give it to the students, and then we can say, okay, now what do we do with this? So that's part of the difference. So those are some of the teaching secrets, and there may be others. And so that basically is the introduction of what you need to know about the administrative details, what are the student requirements. If there's any questions you have, you can ask me when I'm back on Thursday or Friday. I don't actually have any other traveling that's scheduled for the rest of the month. But I want to talk a little bit now about communications, okay? And I always remembered I took a course, a one-day course from a guy, Edward Tufte, who was a professor at Yale, and he's made millions of dollars teaching better communication through graphs and texts and things like that. His course, he would give it, well, when I took it, it was over at the Copley Plaza Hotel. There were 200 people who had signed up for $500 for this one-day course. You got 3 copies of his 3 books, or you got 1 copy of each of his 3 books. And he would get up and he gave these sort of canned lectures. If you work that out, 200 people times $500, that's $100,000 that he was collecting for this one day of lecturing. Now, yeah, he had to rent the Copley Plaza ballroom, and he didn't provide us with lunch. I think there might have been water there or something. And he had 4 or 5 assistants who would walk around because he had made so much money at doing all this stuff. He had been able to go out and he liked to buy old texts, okay? So for example, he had Sir Francis Bacon's copy of Newton's Principia, okay? It had Sir Francis Bacon's name on the inside as the owner of it, and he used to tell us, he would tell us, I paid $40,000 for that book, okay? Well, that was only a morning's lecture, okay? But he would have his assistants carry it around with white gloves and walk down the aisles, okay? And as he was lecturing about the types of graphics and things, communications in some of these books, you could look, but don't touch, okay? You could look at these wonderful books. Well, Tufte he's certainly not the most arrogant person I've ever met, not by a long shot, but he's pretty arrogant, okay? And I could tell you other stories about him, but there's a picture of him, and one thing he said, though, was fuzzy writing is usually the result of fuzzy thinking, okay? And I found that that's entirely true. If you're not quite sure what you're going to say, you're probably not going to be able to say it very well. So that's one thing. Another thing is you've got an assignment to read a paper by Tufte called The Cognitive Style of PowerPoint. Most of you will do your presentations in PowerPoint. I'm doing PowerPoint right now. I never cared much for PowerPoint. Turns out it wasn't until about 3 or 4 months ago that I taught myself PowerPoint. I used to always give it to my secretary or graduate student or a postdoc, and I used to draw out the slides and overheads I wanted done, and I let them type it up. But now I actually sit down, and between all the images you can pick up off the internet of different things, like my little purple fuzzy there in the last one, I kind of go through, and I've been starting to use PowerPoint. And so Tufte hates PowerPoint, okay? His arrogance will come across when you read this article, but he makes a number of good points. In the very beginning, he talks about Lou Gerstner, who was the new chairman of IBM. This was at a time around, I don't know, in the 1990s when IBM was having some serious financial problems, and how Lou Gerstner, I don't know if he told the story about on Lou Gerstner's first day at IBM, the security was so good at IBM's headquarters that Lou Gerstner, the new chairman of the corporation, couldn't get in the building. And it took him a few hours. But in any case, then he gets up and he talks about how everybody's getting up to make presentations. All these vice presidents at IBM are going to tell Gerstner about what's going on and how Gerstner hated PowerPoint, or whether he hated it or not. You can read the story, okay? And you can think about, well, what do you think about Gerstner's approach to trying to listen to people and find out what's going on and learn about this new corporation that he's in charge of. I think Gerstner had been a venture capitalist before he became chairman of IBM. Also in that paper is Tufte goes through and has the Gettysburg Address in 8 PowerPoint slides. If you want to take a great piece of American literature and turn it into pure pap, okay, use PowerPoint, okay? And so there's a lot of problems with using PowerPoint. In fact, a lot of the things that I've just done for the last half hour violate a lot of the things of Tufte's rules about PowerPoint, but you can think about it, okay? One of the things I learned a number of years ago is that the best presenters don't use visual aids at all, okay? The best presenters, think about it. You know, how often does the President of the United States get up and start showing you a PowerPoint presentation? How often do some politician get up and give you a PowerPoint presentation? People who can really engage others don't use PowerPoints at all, and I'm going to give you some examples of that. But nonetheless, you are probably not among the best presenters yet in your career, so it's okay to use PowerPoint, but you ought to use it appropriately, and those are some of the things we'll talk about in the next couple of minutes, okay? I have found that good communications are essentially equal to hard work in enhancing your career. If you can't explain what your thoughts are to somebody else, they might be the smartest, most profound, greatest wisdom in the world, but it's not going to get you anywhere if you can't communicate it, okay? So another assignment, and you'll find these things on Stellar, which is the MIT courseware website, and if you're signed up for one of those 3 courses, you should be qualified to get on Stellar. If not, you can talk to Brian, you can talk to Jerry Hill, and they should make sure that you get access to Stellar for the course if you're registered. So you can read a paper that I wrote called Why Did the World Trade Center Collapse? Okay? And I give that out for a couple of reasons. First of all, about 3 weeks after the World Trade Center collapsed, I got a phone call from an editor of a metallurgical magazine publication and said, "Would you write an article?" I asked Joel Clark, Professor Clark, if he'd write an article, and he suggested that you write the article. You know, I was so sick and tired of reading in the newspapers about how the steel had melted in the super hot fire of the jet fuel. I knew that was garbage. Anyone who's ever been to a fire scene, any fireman knows you don't melt steel in a regular old fire. I don't care if it is a huge fireball with 20,000 gallons of jet fuel or whatever. I mean, I had a blowout in Oklahoma of a 10,000 psi gas well that burned for 3 days, and afterwards the steel derrick has not melted. I mean, it had been engulfed in flames, 10,000 psi gas, air flames, for 3 days. It was oxidized, but it never melted, okay? So I knew that was garbage. But the media, everybody was, oh, it melted, it melted. Sounds like Dorothy and the Wizard of Oz or something. Or no, it wasn't Dorothy, that was the Wicked Old Witch. But anyway, but you have to know who you're going to write for. So I agreed to write this paper, and over the next 2 or 3 weeks, I spent a total of about 3 hours writing this paper. But I knew that I was writing, in my mind, I was writing this paper as if my audience was a good high school science student. Not an MIT student, not some graduate engineer with a college degree, but a high school science student, someone who had had a little bit of science. I was trying to write it, keep it simple, and put it in words and use analogies to things that sort of made things ring true about what it was all about. Well, it turns out the paper came out in December 2011 in the Metallurgical Journal. And for the next 10 or 12 years, if you Google WTC collapse, you would find my paper was the #1 hit in the world on what happened at the World Trade Center. Was I an expert on the World Trade Center? Well, I had spent 3 hours thinking about it, okay, and writing the paper to boot, okay. I spent less time on that paper than any other of the couple of hundred papers I've written, scientific papers I've written in my career. But that paper has gotten more comments, good and bad, over, well, even now. I still get emails from people about this paper. It's no longer #1. It only lasted on the bestseller list, I guess, for about 12 years. I never made any money off of it, but in fact, within weeks of that paper coming out, the people who now call themselves the truthers, these are the people, well, actually it wasn't the truthers. Originally, the truthers didn't exist originally. People who existed were basically anti-Semitites, who basically said that the World Trade Center was brought down by a conspiracy of the Israeli government and the U.S. government to make the whole world upset with, what was the logic? With Arabs, right, yeah, to get upset with the Muslims and Arabs. Well, maybe that was Donald Trump, I don't know, but whatever it was, it wasn't true, and they said, and Professor Eager is an idiot to think that you can't melt steel in a fire that's that hot. Well, and they were writing letters to Chuck Vest, who is the president of MIT, claiming that I should lose my tenure for being such a shill of the government, when everyone knew that, you know, these fires were so hot. Well, you can read the paper. I actually hand it out most semesters now as an example of keep it simple, keep it clear, and the reason people for 12 years kept it on the bestseller list, well, maybe it was because some people were maligning it, but it was also because it was clear, okay? I think it's clearly written, and people could understand it, okay? So I wrote to a large audience. It was a topic of interest. There was a number of things, but I'm going to explain to you how most of the rest of the stuff I've worked on in my scientific career, the things that got me tenure and stuff, have essentially gone nowhere, okay? Because people can't even understand them, okay? So read that with the idea of who was I writing to? I'm telling you who I wrote to, okay? Some other reading assignments for you. There's, on Stellar, there'll be a appendix to a National Academy of Science, or National Research Council, National Academy of Sciences report called Materials to Meet 21st Century Defense Needs. There was a committee of about 30 or 40 people, all volunteers for the National Research Council, got together and we had a number of meetings in Washington and maybe some other places to help advise the Defense Department on what was the materials research they needed to do over the next 15 or 20 years. This was in the early 2000s, so it was kind of set an agenda for the 21st century defense needs. This particular thing that I wrote up, and I'm the author, it doesn't have my name on it, but if you look at the whole book, you'll see that I was one of the participants. But I wrote up my opinion. And my opinion was so contrary to everyone else's opinion, they just kind of took it as I wrote it and made it an appendix. And didn't blame it on me because they thought, oh, but you know, they couldn't take issue with some of the logic. But it wasn't something they were going to incorporate into the main body of the text. Because the main body of the text, they were going to try to sell the Defense Department and Congress and everybody else on what these wonderful nanomaterials and composites and all these other things that we'll never be able to afford to use as structural materials, how wonderful they would be if we could do more research on them. Oh, great. Bunch of crap, okay? So I wrote up something, and anyway, you can read it. My audience in my mind was to help some policymakers who might only read a 4 or 5 page soundbite, okay, on materials. So there it is. I hand that out in a lot of my classes. The next one is a paper I wrote in the early 90s about the future of metals. It was really written to the materials community. What had happened is, and this has been happening for decades and decades, people tend to oversell whatever they've done and make fantastic claims about it. And if you take some of my other modules like material selection, I spend a fair amount of time on this. But what had happened is I spent the 1990s, or mid-1980s, 84 and 85, in Tokyo, Japan, working for the Office of Naval Research. At the time, people were saying, oh, ceramics are wonderful. They can go to much higher temperatures than metals, and we should build whole jet engines out of ceramics. And I thought, what a load of crap, okay? Anybody who knew anything about the toughness of ceramics, they're brittle, by the way, just like glass, okay? In fact, glass is a ceramic. Anyway, anybody who knew anything about this would know that you don't make critical structural materials out of a brittle material. You need ductility, and that's why we use metals. And then people were talking about the photonics revolution and electronics and things, and then people were talking about composites, okay? This Reagan Star Wars, everybody was all interested in composites. So I basically wrote this and made a number of the arguments about, wait a second, folks, you're just completely off the wall. You know nothing about economics. You know nothing about properties of materials and why we select them for structures. So the audience there was the rest of the materials community. I became a poster boy for the steel industry because I said steel's an important material. And you can find out why I said that. Okay, and still true, by the way. The next one in communications, a watershed for me in the early 1980s, no, late 1980s, 1988 to be exact. I was given the opportunity to take the Sloan School of Management program for senior executives. This is a $50,000 tuition, 9-week program where you live down at MIT Endicott House. This is this big old estate. And you listen to Sloan School faculty come in and lecture to you. And I was the only academic, because Lester Thoreau, who had become dean of the Sloan School, and he decided he needed to build bridges with the School of Engineering, and he gave one position of, they essentially gave me a $50,000 scholarship to take this course, and it's sort of a mini MBA, okay? So Lester Thoreau, here he is, he just passed away about 6 months ago, I think. But he was an economics educator. That's how he would define himself. He became the dean of the Sloan School, and he was an author. He was a best-selling author. And in fact, the reason he said he didn't make #1 on the New York Times bestseller list is because Princess Diana's book made #1. He was #2. I think that was head-to-head. But he wrote many books, or maybe it was Zero Sum or whatever. Here's a zero-sum solution. Here's a zero-sum society. He wrote more books than that, but he would be on Face the Nation. Lester Thoreau was one of these people who never had overheads. He would give a talk, and all he had was a little card. I saw it once. You could barely read the words. It was just a little card with kind of a few words about the topics, the themes, the 2 or 3 themes that he wanted to cover. He would get, this is 1988, he would get $30,000 a lecture on Wall Street, just like Hillary Clinton gets a couple $100,000 now. But back in those days, $30,000 was a lot of money, and people were enamored. And in this 1988 program, Lester came in the first time, and we were all enthralled. He was just an engaging speaker. And the second time, everyone was all enthralled. But I was sitting there analyzing, now what did Lester say, okay, that made him so engaging? By the way, his Sloan School faculty colleagues called him less than Thoreau, okay? Because they felt he was being too simplistic in a lot of his arguments here. They could put things in differential equations and things like that, but anyway. Well, what I learned when I listened to him the second time, it's not what you say. He didn't say anything I didn't already know. It was how he said it. And so I took that to heart, and it turns out I completely changed my teaching style. I completely changed what I did. At the time, I was sort of getting to be a big name in the welding community, and I had, for like 3 years running, I had been giving a keynote presentation at the big welding conference that was held every 2 years in Gatlinburg, Tennessee. And so that next year I was going to talk about resistance spot welding of automobiles. And I learned from Lester, you have to make your sound bites, your little themes, memorable. So I said, when I gave my talk, did you know they put 3,000 spot welds in the average automobile because you need 2,000 good ones? And what happened was, a year later, I was at a welding society convention at a cocktail party or whatever it was, a mixer or whatever you want to call it at the end of the day. And I heard someone behind me talking to someone else, and they said, did you know you put 3,000 spot welds in the average automobile because you need 2,000 good ones? So I had taught someone something in that lecture that they remembered, a sound bite, okay? And that sound bite was something that people could remember. So going back to Lester, one of my favorite stories about Lester is when he was dean of the Sloan School, I was over here at the Marriott Hotel in Kendall Square, and he was giving a lecture to a room full of 150 people. And he's talking as the Sloan School dean, and he complained that Harvard Business School, hires away too many of the Sloan School faculty. And as he described it, a lot of us knew he was probably talking about Robert Merton. Now, Robert Merton was Black-Scholes and Merton were the guys who came up with the mathematics for derivatives and all of the derivatives trading, which eventually brought down Wall Street in 2008. But this was like 1990 or so, or early 90s. He says, Harvard hires away too many of our faculty, but he said, fortunately, they tend to hire our extinct volcanoes. And here's a nice extinct volcano. That was his soundbite. That metaphor, you don't have to explain it. An extinct volcano, everybody knows what you're talking about. So if you can make your sound bites memorable, it helps to have some substance behind them, because slogans are not good communications, okay? Whether someone's fighting for us or they're going to make America great again, no one knows what that means. Now, it may mean something to somebody and they kind of put their own color on it, but it means something completely different to somebody else, okay? And the next thing I want to talk, because we've only got a couple of minutes before I finish up here, in communications, is the fact that in Asian cultures, teachers are revered. And salespeople, doctors, lawyers, ministers, they're all doing teaching at some point in their career. You don't have to be in a classroom doing teaching. But as I thought about that and why in the Asian culture teachers are the most revered profession, it's because people like to learn. Well, why are politicians and attorneys so maligned by society? And that's because they spread disinformation, not information, okay? People are not learning. When you listen to a politician or many attorneys, you know that it doesn't ring true. It's not really right, okay? So you want to have things that ring true and have some substance to them. Now, another thing, little final thing in your slides, your PowerPoints, keep them simple, okay? This is an example. If you go to busy PowerPoint slide and Google that, this is one of the ones they'll give you, okay? It means nothing to anybody. And how many presentations do I get from students where they put up something, it's just too busy to see. You don't have time. If you went back through some of my slides, they're pretty simple, okay? And you can understand those a lot better than something like this. So I look forward to seeing you on Thursday. For Tuesday and Wednesday, you can start picking out your modules and watching those modules. There won't be class on Tuesday and Wednesday because I won't be here. Brian showed you all this. If you have some questions, you can ask him. And I'll see you Thursday, and I can answer more questions then. Thank you.